Okay, here's how to find the answer to all three of these questions. Let's start with the difference quotient. So the difference quotient is f of x plus h, everything's all over h, minus f of x here. So let's take a look at the pieces we have and the pieces we need. All over h stays like this, so I can't really do anything about that, but I do know what f of x equals. It's this guy over here. So I would be able to exchange out right now. Instead of f of x, I would be able to make it this over here, like that. However, I don't know what f of x plus h is. So real quick, just to make this clear what I'm doing, so far I'm just swapping out the pieces I know for right now. But the thing is, the only thing I really know is this guy. I need to figure out what f of x plus h actually is. So first off, what does this notation actually mean? Well, the x plus h on the inside means everywhere I used to see an x, it should now be replaced by x plus h. So instead of 1 over x squared, it should be 1 over x plus h squared. Note that I need parentheses here because without the parentheses, this is technically wrong. See that? So I have 1 over x squared. Now it's 1 over x plus h squared. Everywhere I used to have an x, it's now x plus h. So I can also swap this out. Go back up here. Now I know what f of x plus h is. It's this guy. Okay, so this is technically right. However, it would be incredibly wrong to throw this into Pearson the way it is. This needs to be simplified in order for Pearson to accept it. And that's generally the hard part of all of this. Okay, so I'm going to copy this over here underneath this, and we're going to work on simplifying this guy. So I'm not a huge fan of this big fraction bar and then an h. Instead, I'm going to turn this into 1 over h. So, and then I'm just going to leave the numerator in parentheses or brackets. In this case, they're interchangeable. I just don't want to use too many parentheses because I have them here as well. Okay. So this means the same thing as the line above it. For the same reason that like divided by 2 means the same as multiplied by 1/2. That's why I'm allowed to bring this 1 over h into the front. And already that looks better because I don't have double fraction bar, right? Before I had fraction bar here and another fraction bar. So this looks better for one, straight up. Okay, now the next thing I want to do is actually combine these two fractions. However, they don't have the same denominator, so I'm not able to subtract them the way they currently are. So now what I'm going to do is make them have the same denominator by multiplying each fraction on the top and bottom by the piece that they're missing. So I'll write it out and then explain what happened. Okay, so multiplying on the top and bottom is perfectly legal because that actually cancels out to become 1. Sort of like if I multiply by 2 and then divide by 2, it's like I did nothing. That's what I'm doing here. I'm multiplying by x squared, and then I'm dividing by x squared. So it's like I did nothing. Same thing over here. I multiplied by this parentheses squared, and I divided by it right away, so it's like I did nothing. The reason why I needed to do that, though, is now my fractions have the same denominator. Right? This denominator and this denominator are now the same thing. That was why I needed to do that. Okay? If you're still not sure why this works, try working out a numbers example. If I have 1/7 minus 1/5, well, I can't do that, right? Because they don't have the same denominator. So what I would need to do is I'd have to multiply by 5, multiply by 5, multiply by 7, multiply by 7, and it's exactly the same thing, right? Exactly the same thing except with numbers. This would be 5, and this would be 35, this would be 7, and this would be 35. So you can see when I correct the denominators by doing this multiply trick, it makes the denominators the same, so I can actually do the subtraction. So if you're ever confused, you can always just take it back to numbers and see why it works out that way. Okay, so now I actually need to subtract the two fractions. And the nice part is it looks pretty easy to do that. All I'm going to do is smush the tops together and leave it like this. Okay, now I need to expand out this parentheses. Essentially, I'm not done simplifying yet, right? But the way that I expand this out is just using FOIL. So this is going to be x squared plus 2xh plus h squared. And what I'm really doing there, I didn't write it out, but what I'm really doing is x plus h times x plus h. And then I distribute, right? I do my little FOIL. And when I do that, it gives me this guy. Okay. And now I also need to remember to distribute this minus over here. So this is going to be minus x squared minus 2xh and minus h squared. And now I don't need the parentheses anymore. The nice part about this is now I have x squared and x squared. These two things will cancel each other out. So on the next line, I'm going to get rid of them. I'm going to delete them. Now, finally, I am almost done. Finally, I see this 1 over h in the front. This is another way to say divide by h, right? We established that in the very beginning. What I see here is I have an h in this term, and I have two h's in this term. So one h is going to cancel out from this guy and from this guy. So real quick, just to draw these lines, I'm saying x squared minus x squared cancels out to give me this line. And now 1 over h cancels this h out. And it's only going to cancel out one copy of h here. So I'm just going to scribble out the 2 because now that should just be a regular h instead of an h squared. This is gone. This is gone. I don't need the brackets anymore. And now I'm left with this. This would be my final difference quotient. Well done. Okay. Next up for the word problem. The revenue in dollars from selling phones is this. The cost is this. Profit is typically revenue minus cost, and you can see that that's what they're saying here. So finding the profit function is just as simple as doing what it says on the tin. So P of x is equal to R of x minus C of x. But what are R and C? They were given to me right here. R is this guy, so I'm going to swap out R with what they told me it was. Negative 1.8 x squared plus 191x. That was the R they gave me. Now I have to subtract the cost. The cost is this guy over here. Careful, I'm going to put this in parentheses. So that's 0.07x cubed minus 2x squared plus 55x plus 750. And if you want to be technical, that's kind of it. Like, this is the profit function. However, it would be wrong to put this into Pearson because it's not simplified yet. I'm going to do the same thing I did before where I distribute this minus. So that wraps this around to being a plus. This becomes a minus, and this becomes a minus as well. And now I no longer need the parentheses. Next up, I'm going to combine like terms. So this guy is x squared, this guy is x squared, this guy is regular x, this guy is regular x, and now the last two things are not like terms with anything, so they can kind of just stay put. Negative 1.8 plus 2 is going to be positive 0.2, so now I don't need this. 191 minus 55 is, I'm going to type that into a calculator because I can't be bothered, 136. So this is going to end up being 136. And I don't need this guy. Now it's written not in descending order. So sometimes you may see it written like that, just so that way it goes power of 3, power of 2, power of 1, and then no x's at all. But this would be your final profit function. Part 2 is just saying, what do you get when you plug in 15 for x? So all you would want to do is take this guy. Everywhere I used to see an x, it should now be 15. Please use a calculator for this. You do not want to calculate this by hand. But this would be your answer to part B. Interpret P of 15. This is asking you for what does this mean in the context of the question? In the context of the question, what does X represent? It says from selling X cell phones in hundreds. This would be cost in dollars in hundreds. So this is if we sell 15 cell phones, the profit is whatever you got from this thing, right? So I'm going to copy paste it here, but it would be the number, whatever this was, whatever number this comes out to. Okay, and for finding the domain of this function, step 1 is assume you've got all real numbers. Assume everything works. Step 2 is look for fractions. I do see a fraction. I have the denominator is not allowed to be 0. If the denominator ends up being 0, I get a divide by 0 error. So I would take my entire denominator, which is square root x plus 4. That's not allowed to be 0. Okay? The opposite of a square root is a square. So I need to square both sides. So here's a square, here's a square. Square and square root cancel each other out, and it just leaves me with what was underneath the root. 0 times 0 is 0, so that simplifies like this. Now I would want to subtract the 4 from both sides, so I get that x does not equal 4. Next step is ask myself if I have any square roots. I do. I do have a square root in the denominator. Underneath the square root has to be 0 or bigger. In other words, greater than or equal to 0. You can't square root a negative because that will give you imaginary numbers. And for the time being, we don't care about imaginary numbers. So I would have to say that underneath my square root, which is x plus 4, needs to be greater than or equal to 0. I need to have this be true. Whoopsie. So the next thing I want to do is solve this inequality, and I get x must be greater than or equal to -4. The next thing that I want to do is combine this result, combine that result with this result, because both of those highlighted yellow things need to be true. So the only way that both of them are true is if I look at the overlap. So here's my number line, just going to quickly sketch this out. So here's my -4, and I'm just going to write like some other numbers on here just to prove that we're going like the right direction. So this one result right here says I need to fill in my dot at any numbers greater than or equal to -4. So that would be this way. And now I'm going to graph my other guy up here. This one says everything except -4 works. So that's going to be an open circle, and everything except -4 works. So the only places where both of these things are true is from here onward. It's literally the overlap. So you'll hear me reference this in class as the place where the functions overlap or the place where the inequalities overlap. This is what I mean. They literally are on top of each other when you graph them. So you'll notice this part right here does not count. This is not overlap. This one has an empty circle, so this one doesn't include the point, and this one does include the point. So they do not overlap each other right there. For the same reason that this green doesn't overlap any red. Only one thing is true here. And right over here, only one thing is true. So my answer is really, when I combine both of these things where both of them need to be true, it's actually just x is greater than, sorry, -4. I don't actually include -4. It works for this guy, but it doesn't work for this guy. And since I'm worried about where both of them are true, it's got to be just this. I think the question wants you to write this in interval notation, though. So this would be inequality notation. Interval notation would be -infinity all the way up to oh, I'm so sorry, this is not correct. That would be -4, infinity, like that. We do not include the value of -4, so it should be like this. This is for interval notation. Okay, and this is how you do all 3 of those problems.